Hello and welcome to week 8 and chapter 11. Please note that exam 3 is next week. There is going to be a study guide posted. This exam will be in a similar format to your first exam. So it'll be somewhere between 45 and 50 questions. It'll be an hour, and this time it will be available all day on Thursday as opposed to Friday. And if you have any issues with that schedule, please let me know as soon as possible so we can make those changes. This chapter we're going to start by talking about very basic forms of carbohydrates, which are sugars. So we'll talk about the roles of sugar in cooking, and we'll talk about its very structural components. And then after this chapter, we're going to move on to 13 and 14, which will talk about different, more complex types of carbohydrates, including starches and different types of grains. In this chapter, we're mainly going to be focusing on sugars or simple carbohydrates, but know what the structure is of simple carbohydrates and complex carbs, and then be able to provide examples of each. Know the health effects and functions of carbohydrates, both good and bad, and we've talked about some of the main roles that sugars have in baking, be able to recognize these. And then we're also going to talk about crystallization, which is an entirely new concept. So know what crystallization means, and with crystallization we're going to be using a term called saturation. Know what saturation means and know what the different levels of sugar saturation represent. And then finally we'll be looking at sugar substitutes. Recognize the baking challenges that are associated with using these, as well as the health benefits and health consequences that they are associated with. Carbohydrates come in two major forms, sugar and starch. Sugar is very simple and basic. It is just one or two molecules, whereas starch is complex and contains many molecules. In the picture above, you can see this. Glucose and sucrose are two forms of sugars, or simple carbohydrates. Glucose is just one sugar unit and sucrose is two sugar units, but both of these are still sugar. So sugar can be either one or two molecules. The blue hexagons are not perfect representations of a simple single sugar unit, but for this class, let's pretend that they are. A starch molecule is simply a long link of sugar molecules. A starch molecule includes at least 10 sugar molecules, but it can be up to thousands of individual sugar molecules. When we eat starches or sugar, they will break down into sugars regardless of how many molecules are linked together. We have already discussed this concept back in previous chapters, but it's a very important one, so I really would like to revisit it. Simple carbohydrates are just sugars, and complex carbohydrates are just starches. Many people believe that simple carbs are unhealthy and complex carbs are healthy. By itself, this is not true. It's very not true. Simple carbs come in healthy and unhealthy forms. You can get an apple that has many vitamins, minerals, phytonutrients, antioxidants, and fiber, and this is still a simple sugar. You can also get a 12-ounce can of soda, which has sugar, and, well, that's about it. It is pretty much just sugar. And that's when simple carbohydrates are bad. White bread is a form of a complex carbohydrate. It has a lot of carbohydrates and a little bit of fiber and a few nutrients. White bread is refined, and during the refining process, many nutrients are removed. Some are replaced afterwards, but a good amount of the damage is already done, and many other nutrients that we know less about are lost forever. Quinoa, on the other hand, is so close to being the perfect food. If you eat quinoa on a daily basis, you're doing very good things to your body. It has so much iron, which helps to deliver oxygen efficiently throughout the body. Consider somebody that has very slow-moving oxygen to their brain. It's not a good thing. Quinoa also has a good amount of protein, so when you eat quinoa, it's going to be broken down and absorbed more gradually, providing you with longer lasting energy throughout the day. If you put some tomato sauce and cook a few vegetables with this dish, you really cannot go wrong. Of course, you can overdo apples and you can overdo quinoa, but it's much more difficult to overdo these foods than it is white bread and sodas. Some of this has to do with the fact that the processed sugars and the processed grains, such as the sodas and the white breads, have fewer nutrients that regulate our appetite, which makes us more likely to overeat. The processed foods are also not as well recognized by our bodies, and because of this, there is a greater chance that our bodies will produce an inflammatory response when we eat these foods. The main role of carbohydrates is to provide the body with energy, and carbohydrates do a very good job of this. While fats provide energy for many of our functions at rest, it is still essential that we eat plenty of carbohydrates because carbohydrates help to fuel our body in many ways, even when we are not exercising. Now, if we are exercising, carbohydrates become increasingly important, regardless of the exercise that we are doing. Carbohydrates, they fuel high-intensity activities. Now, if we are lifting just one weight or doing a move that will last 0 to 10 seconds, we may not be using carbohydrates for that exercise, but our bodies will still be relying on carbohydrates when that activity is over because our heart rate is very elevated. It also heavily relies on carbohydrates during prolonged, intense physical activity, such as running around the track 1 to 4 times at a high intensity. If you ever hear a famous athlete say that they are on a low-carb or a no-carb diet, look into this a little bit further. Many times they are still eating fruits and certain grains that they may not consider carbohydrates, but they certainly are carbohydrates. They may eat fewer carbohydrates than what our national dietary guidelines may recommend, but almost always a very good portion of their calories still come from carbs. And actually, there are many athletes that follow high carbohydrate diets. If we do not get enough of our energy from carbohydrates, our body has to find another energy source, and we can use protein, but this is not as simple as it sounds. Protein is not very efficient at being converted into energy. We do not simply eat protein foods and then use that protein immediately for energy when it is digested. We use the protein that is stored in our muscle tissue. So if we are very low on carbohydrates, we will have to rely on the breakdown of our muscle tissue for fuel. Not good. Carbohydrates are needed to oxidize or break down fat. So if we lose weight following a low-carb diet, most of the weight that we lose is not the weight that we want to lose because we cannot oxidize fat. That means that we cannot break down and burn fat. And then finally, fiber is a type of carbohydrate that's found in many whole food sources. Fiber has a few roles in our body, but its main ones are to promote digestion and to prevent plaque from building up in our arteries. Fiber keeps things moving through our digestive system so that we do not have constipation or things that are lodged in our GI tract for an excessive amount of time that could cause constipation and inflammation. And then also it helps to prevent the development of plaque in our arteries, which helps to prevent against chronic disease such as heart disease. So all the health problems with carbohydrates are usually related to eating too many carbohydrates and eating the wrong types of carbs. So first, if we eat too many carbohydrates, the carbohydrates that we eat are going to turn into fat. But guess what? If we eat too much protein or if we eat too much fat, our body will turn these nutrients into body fat as well. And also, we are more likely to eat excessive amounts of carbohydrates if we eat processed carbohydrates that are low in nutrients such as fiber that signal fullness and regulate appetite in our bodies. Refined processed carbohydrates can also cause inflammation in the body. This inflammation occurs internally and is something that we cannot see, but it is associated with many diseases, one of these being heart disease. Heart disease occurs when we have large amounts of plaque in our arteries. The picture on this slide shows a healthy artery, which is on the left, and compares it to arteries that have some plaque buildup in them. Inflammation can occur in our arteries, so if we eat a food that has a chemical or a nutrient that our body does not like or does not recognize, there is going to be some inflammation that's generally caused. And this is one location that the inflammation can occur, inside of the arteries. So to respond to this inflammation, our body is going to deposit cholesterol and fat around the location that was injured. And the body has good intentions, but if this continues to happen, eventually our artery will get smaller and smaller because the plaque continues to develop around it. And over the long run, this will lead to a blockage of that artery, which will cause a heart attack. So if we eat many foods that are processed and related to inflammation development, we are going to put ourselves at a greater risk for heart disease and for heart attack. So you already know many of the roles that sugar has in baking. We're just going to review some of these roles and mainly look at the most essential roles that sugar has in baking. These being increasing moisture content and then contributing to the structure of baked goods. Sugar is attracted to water because sugar and water both have slight positive and negative electrical charges. You don't have to know this, but this helps to explain that concept. Positive attracts to negative and vice versa. So flour absorbs water, but it more so uses this water to form gluten bonds, whereas sugar attracts water and simply retains it or keeps it in the baked product due to these electrical charges. And as a result, by retaining that water and keeping it in the baked product, that food is going to be much more moist and more tender. When mixed with water, protein and gluten both form a strong structure for baked products, a very important role. Without protein and without gluten, baked products would simply crumble and not stay together. However, it is possible for there to be too much stability in baked products. For baked products to reach their final desired texture, we need to have a solid structure. However, again, they can't be too tough, in which case their texture will be undesirable. By adding sugar to breads, we can prevent gluten and protein from taking all of the water. Before moving on to the next topic, let's review what happens in foam cakes. So foam cakes have a very light and spongy structure, which you can see in the picture of the angel food cake below. This occurs from the whipping of eggs, which incorporates a great deal of air. When heated, the air produces steam, which allows for the expansion of the foam cake, giving it that very light and fluffy structure. Coagulation is the binding of protein molecules to form a more stable structure. And this happens when you cook eggs. When you first crack open an egg, it is very runny and it's not at all stable. When you cook it, that's when it develops a very solid form. This solid form is the coagulation, or the connection of proteins between one another to form that final solid product. Now, if the coagulation occurs too quickly in a foam cake, it will be more likely to bind up and clump together. The sugar fights against the coagulation process, preventing this binding from occurring too early, which would not allow for this light and fluffy structure to grow and develop. Caramelization is simply the browning of sugar that occurs when sugar is heated above 300 degrees. This produces a nutty flavor and a brown color in the food. We can see this when we cook potatoes or toast bread. This browning, where just the carbohydrate is heated, is an example of the caramelization reaction, which is different from the Maillard reaction. Crystallization is just related to sugar, and we're going to talk about how it's affected by saturation in the next slide, but the very basic definition of it can be described here. So crystallization involves more sugar in a solution that can be held by a solute, resulting in the formation of crystals. So we're just packing some type of solute or some type of liquid with sugar, more than it can handle, and that is going to form crystals. Certain sugars require crystallization to create their structure, and these include candies like rock candy, fudge, and fondants. Crystallization is a form of saturation. Saturation is a term related to a solution. So let's start off by explaining what a solution is, then describe saturation, and from here we can go on to explain the crystallization of sugars. So a solution is a mixture of a solvent and a solute. These are both really simple concepts. A solute is a liquid and a solvent is a particle. An example of a solute is water. An example of a solvent is salt or sugar. So we mix these two things together, and the combination of the two, the combination of the solvent and the solute, is a solution. Now there are three levels of a solution. There are unsaturated solutions, saturated solutions, and supersaturated solutions. When we add sugar to water, there is only going to be a certain amount of sugar that the water can absorb. So we add a little bit of sugar and it is dissolved. We add a little more sugar and all that sugar is dissolved. We keep adding sugar and finally most of that sugar is dissolved, but then there are bits of sugar that are not dissolved and that will sink to the bottom of the mixture or will still remain present in their sugar granules. And this describes saturation. Unsaturation means that the solvent is completely dissolved in the solute and that the solute could hold more. So if we were talking about sugar and water, we would stir up sugar in the water and it would mix completely in. So all we could see is a liquid or the solution. But if it is unsaturated, we could still add more sugar and it would still mix in to the point where we would just see the liquid. So in an unsaturated solution, there's still more of that solvent that can be added to the solute. Saturated is the perfect middle ground. This means that we have figured out exactly how much of the sugar should be put into the water to perfectly mix. This means that we will see a clear solution, but if we added one more tiny particle of the solvent, it would not dissolve. It would simply sink to the bottom. And this describes a supersaturated solution. A supersaturated solution occurs when we have completely mixed the solute and the solvent into a perfect saturated solution. And then we add just a little bit more of the solvent. So when we mix this all together, the water cannot absorb all of the sugar. So there will be small sugar particles floating around the water. This may sound strange, but crystalline candies are surprisingly smooth and soft because although they have crystals, their crystals are very fine and tiny. Crystallization is a rather funny process. It does not make much sense, but at the same time, it sort of does, and you'll see why. To perform crystallization, we must heat the water-sugar mixture. There may be other ingredients such as fat, which will actually make crystallization more difficult in this mixture, but that piece is not essential to the story. For crystallization, we will mix together the solvent, which is sugar, and the solute, or the liquid, together to form a solution. To create crystalline candies, we have to trick the candy into holding more sugar than it can hang on to through supersaturation. So to do so, we create an unsaturated or saturated solution with sugar and water. We heat the sugar-water mixture, and when we do so, the water is actually able to do a better job of dissolving and holding on to sugar. But because we are heating the water and boiling it, we are starting to lose some of that water. So that water is going to start floating up into the air as it boils and evaporates, but the sugar is not going to do that. It's going to stay in the water. And as we lose more and more water from the steaming, the concentration of the sugar is going to become much higher. It is when we start to cool the mixture that crystallization can occur. As the temperatures of water get lower and lower, the water does not do as good of a job at dissolving sugar. So the sugar becomes saturated and then supersaturated. If it's cooled too quickly, then too large of crystals will form. Rock candies do have larger sugar crystals, but most candies need very small and fine crystals. And to get these fine crystals, we need a very gradual cooling process. So the cooling temperature that we are bringing crystalline candies to is a relatively high 104 degrees Fahrenheit. Because we've gone through so much in the previous slides, we're going to keep the remaining portion of this PowerPoint relatively short. I'm just going to go over the basic points of each of the following slides. So when we're cooking with sugar substitutes, it's important to understand that sugar has many roles in cooking outside of providing sweetness. It promotes structure, holds moisture, and acts as a leavening agent. The chemical structure of sugar substitutes are somewhat different from sugar. So we need to consider what can go wrong when we're using sugar substitutes in place of the sugar and then adjust the recipe accordingly. So it's possible to use liquid sources of sugar instead of granulated sugar. The purpose of this is largely related to the fact that syrups, molasses, and honey are going to provide a slower release of sugar, which is going to give us longer lasting energy and is less likely to create inflammation in our bodies. With these, we have to use less liquid, cook to lower temperatures, and add a basic ingredient such as baking soda so that leavening is able to occur because all of these ingredients are relatively acidic. Low-calorie sweeteners are sweeteners that have less or negligible amounts of calories. So some of the ones that you may be familiar with are stevia, aspartame, Sweet and Low, or Splenda. And these are all generally safe in limited quantities. Many people consider stevia to be the best option, but there are still complications related to its intake. So a good general rule to follow with all of these is to consume these moderately. So only have these maybe 1, 2, 3 times tops on a daily basis.